Sommerville, Agile Software Development. I'm going to go through this a little faster than some of the others because there's a lot to read and I don't want to read it out. But we'll see how we go. So this talks about Agile methods, Agile development techniques, Agile project management, and how do we scale Agile methods. So the idea is that we want to do things quickly and rapid development and delivery is now often the most important requirement, right? Plan-driven development doesn't meet that business need, so Agile development has taken its place. What that means is we specify, design and implement in an interleaved way, and we develop the system in a series of versions or increments or sprints with the stakeholders, the customer, heavily involved at each stage. So we frequently deliver new versions for evaluation, and we need to have extensive tool support, and the focus is more on working code rather than necessarily extensive documentation. So this is just an attempt to put together a diagram about the differences between plan-based development and Agile development. Plan-based, we go requirements, requirement specification, design and implementation, and once the requirements change, we go back and do it again. Whereas with Agile, we do requirements, we do design, we do requirements, we do design, and it's much more of a fluid backwards and forth motion between those two. The plan-driven development, it's around separate stages of development, whereas Agile, all of those stages still happen, but they happen in a much more interleaved or fine-grained way. So this is just talking about the dissatisfaction. The focus is on code rather than design. It's an iterative approach, and it's intended to deliver working software quickly and adapt or evolve that software based on changing requirements. And there's a thing called the Agile Manifesto, and this is a statement of it. We are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. That is, while there is value in the items on the right, we value the items on the left more. Right, and they're some of the principles of Agile methods, and I'm not going to read through them, you can read through them. And what is this saying? Custom system development within an organization. Yeah, you can apply Agile methods. It's particularly useful when you've got a product owner, whether that product owner is within your company for improving the existing product that your company sells, or whether that product owner is with a customer that you're delivering software to. That is where it really shines. So extreme programming is one approach to iterative development, and let's just have a quick look at that. You select the user stories for this release, you break down the stories to tasks, you plan the release, you develop, integrate and test that release, you release the software, you evaluate it, and then you select new user stories for the next go around. There's some specific pieces of things that you do that extreme programming says you should do. So incremental planning, don't do it all up front. Small releases, don't expect a big bang at the end. Simple design, only design enough to satisfy the current requirements. Test first development, right? Here, the idea is that you write a test before you add any new functionality. You write the test fails because the new functionality isn't there yet. You write just enough code to make the test pass, then you do it again. It's also sometimes called red-green programming, red meaning test failure, green meaning test pass. Once you've got all those tests, automated tests in place, then refactoring is easy, right? The idea with refactoring is you reorganize the code to make it better. And you can't really do that with any confidence unless you've got a suite of tests to make sure that you haven't broken any past functionality. Another aspect that extreme programming says you should do is pair programming. So here developers work in pairs. One of them driving the computer and the other one looking on, and then you swap. Extreme programming expresses collective ownership. Extreme programming requires continuous integration. As soon as you've finished a piece of functionality, it gets integrated into the overall system. You want a sustainable pace. You don't want to burn everybody out. So large amounts of overtime is not considered acceptable. You want everybody to work at a continuous rate. And a key piece of extreme programming is you need deep customer integration, right? They need to be very aware of what you're doing, and you need to be able to talk to them about what you're doing on sometimes a daily basis. And you can read this as well as I can. I think this is about tying the Agile Manifesto to the practices in extreme programming. So the key pieces out of extreme programming that a lot of places use are user stories for specification, refactoring, test first development, and pair programming. So the idea with user stories is they're a way to express requirements, and they should be written usually on cards, and then within those cards you figure out what the tasks are that need to be doing. Right, so here's an attempt at a story. This one's a little long, and I'm not going to read it. You should read it out of the slide deck, and then within that there's various tasks that need to happen. Refactoring. Right, so you want to be able to refactor, constantly improve code when you have a new requirement. And the idea of refactoring is it doesn't change the behavior of the code, it just changes the internal organization of the code. Maybe you want to change the organization of the code in order to meet a new requirement, but the actual refactoring does not meet that new requirement. You have to add new code to meet the new requirement. There's lots of reasons you could refactor. Usually it's a slight change in design. Sometimes it's about understandability. Sometimes it's about new components that you need to use, or replacing old components with newer versions. It's a practice that you should get used to. Here's some reasons you might do it: removing duplicate code, renaming attributes, replacement of inline codes with calls to methods. So test-driven development is central to XP, Extreme Programming, and the idea is that you test first and you have you develop those tests from scenarios. A scenario is if you like, a walk through a use case, and you have to involve your customer in both test development and validation, and the aim is to have those tests automated. One good thing about writing tests is that it often clarifies the requirements before things are implemented. If you don't have enough information to write the test, you certainly don't have enough information to write the code. Agile needs customer involvement. It can be on a periodic basis, but it needs to be on a frequent periodic basis. You want the role of the customer to be involved in the acceptance test, be involved in discussion about the product. And the problem is the customer role is not generally within your organization. So you need to find a way of working with them that means that you can make use of their valuable time. I'm not going to go through this example. This is an example test case. We've got the input, you've got the tests, you've got the output. Test automation is a huge thing in Agile methods. You want to be able to test everything to make sure that it works. You may want to test a subset, but there are lots of nice frameworks around: XUnit, JUnit, CPP unit, lots of different automated testing frameworks. One of the problems with test-first development is programmers prefer programming to testing. Some tests can be hard to write incrementally, and it's often difficult to judge the completeness of a set of tests. Okay, pair programming. This involves people working together, right, on the same code, usually on the same screen. It can be done remotely. One of the big benefits of pair programming is that it helps develop a common ownership of the code and good communication between people who pair. It also serves as an informal code review process, and it encourages refactoring, as the whole team can benefit from that refactoring. So pairs sit together at the same computer to develop the software. You don't want pairs to be fixed, so you want different members to work together at different times. And this is even experienced people working with inexperienced people. That can be very good, because the experienced people can teach the younger person, or the less experienced person, about the code that maybe they're more familiar with, and the less experienced person may know more about the latest and greatest technology, which the more experienced person can also learn. So it's a two-way street. Okay, Agile project management, and this is covered in a whole separate course. And the thing is, the aim with Agile is to give the team the ability to do their jobs, and that's can be a little different from the way a standard management practice works. There is an Agile method called Scrum, and there's 3 phases, outline planning, series of sprints, and then closure. Right. In Scrum, there's a development team, and usually no more than 7 people. The idea is that at the end of every increment, you should have a potentially shippable product. There is a product backlog, which is the list of things you need to do before you're done. And there's the product owner, who is in charge of deciding what goes in the product backlog and the priority of those items. The Scrum is a daily meeting. I usually call it a daily stand-up meeting, where you identify what's happening with each person on the team. When I run those sorts of meetings, I usually get people to answer 3 questions. What have you done since the last meeting? What are you going to do before the next meeting? What's stopping you getting it done? The Scrum Master is sort of a project manager, but not. The aim with a Scrum Master is to help the effectiveness of the team, right? The aim for them is to remove obstacles for the team. A sprint is just what they call an iteration, and it's usually 2 to 4 weeks long. And then the velocity of the team is how much effort the team gets done within each sprint. And that's done by looking at the number of user stories that are done. Sometimes those user stories have points associated with them, looking at the number of story points done per sprint. Okay, and this is roughly how things work. You review the work to be done, which may change the product backlog. You select the items from the product backlog that are going to be done. You plan the sprint. You put those product backlog items into the sprint backlog. You do the sprint. You review the sprint, and at the end of the sprint, you have a potentially shippable piece of software. And I've already talked mostly about that. Right, the third point there is a key about the Scrum Master. The role of the Scrum Master is to protect the development team from external distractions. Okay, and then at the end of the sprint, the work done is reviewed and presented to the stakeholders, including the product owner, and then we start planning the next sprint. Just talking about Scrum Master, and the whole team needs to attend those short daily meetings. They should be short. They should be no more than 5 to 15 minutes long. Again, I usually call them a stand-up, because if everybody's doing it in person, I make everybody stand up. Because if everybody sits down, they get too comfortable and things take longer. Or if you're standing up, you want to get back to your desk, so stand up to do it. Right, here's some benefits. Products broken down into manageable chunks. We don't hold up progress because of unstable requirements. The whole team has a visibility into everything. Customers see on-time delivery in increments, and it improves the trust between customers and developers. It's possible to do distributed Scrum, but you have to have real-time communications, and as the current situation has shown, things like Zoom or Slack or Skype or Teams or Discord all work to help with those. One of the problems is, as I think I said earlier, the Scrum Agile methods tend to work best with teams of 7 people. What happens if your project is much bigger than that? Well, then you need to scale, right? And the scaling depends on how we need to figure out how to do that. And there's scaling up, which is concerned with using Agile methods across large software systems, and scaling out, which is how methods can go across the organization, right? And it's important to maintain the fundamentals: flexible planning, frequent releases, continuous integration, test-driven development, and good communication. Agile is a little bit informal for some large companies, and it's most appropriate with new software development rather than software maintenance. And Agile is best done with co-located teams rather than distributed teams. The problem with Agile when it comes to software contracts is usually software contracts say what you have to build, and that's what gets paid. Whereas Agile says, I don't know what I'm going to build. I'm going to build as much as I can each 2-week or 4-week sprint. So there's a bit of a problem there. And one of the key problems with a lot of Agile teams is if you can't keep the team together after the initial product is released, then it's harder to maintain the product. Right? Because it's Agile, we don't have the documentation. We've got to keep getting the customers involved in the development, and having that continuity can be a problem. And I'm not going to read through this. Right, so this is just some of the things that we need to do within an organization for Agile. And these are some of the things that impact the way we deliver things. Within an organization, there might be contracts, there might be delivery, there might be a culture. Within the team, there's technology, they might be distributed, they might have different levels of competence, and then the system itself might have a particular type, might have a scale, or regulations, or a lifetime. So when we talk about Agile development for a system, we need to think about how large is it. We need to think about what type is being developed, and we need to understand how long the system is going to live, and whether the system's going to be impacted by external regulation. We need to know how good our designers and programmers are. We need to know how the team is organized, and we need to have some sort of support technologies. Maybe there's IDE support or visualization or programming. Traditional engineering groups have a plan-based approach to development. So that may be a problem within an existing organization. So it's possible that larger organizations are going to be very hard to work in an Agile way. So how do we work with a large system and agilely? Right? Large systems are constrained by external rules and regulations. They have a long procurement and development time, and they have a large group of stakeholders. Right? And there's a diagrammatic approach to the different things that may impact working on a large system. And this is IBM's approach, where at the core we have the Agile development. In the middle you have a disciplined Agile delivery, right? So risk and value driven life cycle, self-organizing with appropriate governance and framework, full delivery life cycle. Then the outside is disciplined Agile delivery, where you have large team size, geographic distribution, regulatory compliance, etc. Scaling up large systems, right? You can't with requirements. So oftentimes you do need that full set of requirements up front. There's no single product owner. It's not possible to focus only on the code. cross-team communication mechanisms need to be put in place, and continuous integration may not be at all possible. So the one I've worked with before is called a Scrum of Scrums, where each Scrum team meets on a daily basis, and then on a sometimes daily, sometimes bi-weekly basis, the Scrum Masters of each of the Scrum teams work together to coordinate work across the different teams. You've got to have release alignment. You need sort of cross-cutting people as product architects, and it's possible that you have role replication across those different teams. And here's some other issues to do with Agile across different organizations. That last one is probably the key one for me. There may be cultural resistance to Agile methods, especially in organizations that have a long history of using conventional systems engineering processes. Okay, so the key points are Agile methods are incremental. Agile development practices include user stories, frequent releases, continuous integration or continuous improvement, test first, and customer participation. Scrum is one way of doing it. It's not the only way. Many practical development methods mix plan-based and Agile, and scaling Agile methods for large systems is difficult. It's not impossible, but it is difficult. And that is chapter 3.